All right, 4.3, solving systems, linear equalities, notes. I have another video of this that I did and the sound didn't show up. So I'm going to do this one a little faster. If I go a little too fast, there's the other one you can kind of watch where I'm doing it slower, but you can't hear me. But let's get after it. So it's just a combination of what we did last chapter. I'm just doing it twice. So I look at this first one and I'm like, okay, I have a line, a slope of -2, and my b, my y-intercept is 4, so my b is where I begin. Slope of -2 goes down 2 over 1, 2 over 1, 2 over 1, boom. And since it has the equal to bar on it, it's going to be a solid line. And I'm going to do the other one in blue. Actually, I'm going to do the other one first. I'll do this one now. Crosses at -3, that's my b. My slope is 1 positive, so up 1 over 1, up 1 over 1. This does not have the bar underneath the inequality symbol, so this will be a dotted line. All right, now I got to get my shades going on. So this first one, since it's less than, I'm going to shade below. I'm going to shade under the line. All right, and with the blue one, it's greater than, so I'm going to shade above the blue line. And basically, the answer, the solution region to the problem is the double shaded area. So all of this area right here, all the ordered pairs that live inside there, that is the solution region. And you can punch that in Desmos and it'll shade it really nice, really pretty for you. All right, go quickly through the next one. I have a y-intercept at 2. Slope of 3/2 goes up 3 over 2, 3 over 2, 3 to 2, 3 to 2, 3 to 2. We have a bar, so we are a solid line. And I'm shading greater than, so I'm shading above. I'm just going to draw a couple little arrows. We're going above. And then x is less than 3. Well, this cannot be written in slope-intercept form. So x in a number, those are vertical lines. So it's going to be dotted because there's no bar there. So that's the line x equals 3. Well, x less than 3 is shaded in this direction. So the double shaded area would be all of this area over here. That got shaded by blue, it got shaded by red. That would be the double shade. All right, so number 3, we've got a word problem here. It says a charity is selling t-shirts to raise money. Cost of a t-shirt, $15 for adults, $10 for students. That's kind of a tip-off. I'm going to have a system of equations because I have 2 different people or prices going on. I need to raise at least $3 grand, all right? And we only have 250 t-shirts. So obviously if I sell more to adults, I'm going to make more money. Less to adults, less money. Couple different ways I could do this. Let's first draw like the classic system. So I'm going to do my money equation. And we'll use A is going to be the number of adult shirts sold. And let's do S for the number of students. And so for my money equation, I have $15 times every adult, and maybe just, maybe we ought to just use X and Y since I have X and Y in the grid over there. Might make a little bit more sense. So 15X plus 10Y has to be at least 3,000. So remember, at least means I need to be greater than or equal to, which is kind of not intuitive. At least you might think less than, but then I got to do the quantity. We only have 250 shirts. So however I sell it, when I do the number of adult shirts plus the number of student shirts, it's got to be less than or equal to 250. That's my constraint. I can't sell more than 250 shirts. I might not sell them all. So I'm going to try to put this on the grid. I'm going to slide this grid up a little bit just so we can see the x-axis down there on the bottom. So let's come back for me. All right, so here we go. So if I want to graph these these two lines. I could, solve them both for y and kind of put them in slope-intercept form. I kind of like using, using intercepts on this one. That's kind of something else that I could do. So maybe for this one, let's just make a little xy table, and let's just find the intercepts. So when x is 0, you can't see my hand, but I'm covering up the 15x. 10y is 3,000, so y must be 300. So meaning that I need to sell 300 shirts, kids' shirts, if I'm going to make my $3,000. So 0 for x, 300 for y, that's way up here. And then if I do 0 for y, 15 times what? Well, I need to sell 200. If it's just all adult shirts, 200 adult shirts at 15 bucks, that'll be my $3,000. So I kind of use the intercepts on that one. Now I'm going to connect these two with a line. So this was graphing using intercepts because I didn't feel like solving those both for, for slope-intercept form. I didn't feel like solving them for y. So there's that line. And I need to be greater than, so if I were to solve for y and move everybody over, my y would still be greater than. So I know that we're going to be shading like in this direction. So over here is where the money's going to be made, where I'm going to meet my amount I need. The one underneath it, I could do the same type of table. So for this one, I could do a quick little XY table. This one's not very interesting. It's 0, 250. Or 250, 0. So from 250 over here to 250, connect those lines. And my grid's pretty big on this board, so it may not cross perfectly where it's supposed to. But it looks like it's crossing somewhere right around in that area. But we don't really care about that. We care about the overlap. And on this one, it's going to be shaded below because it's going to be y is less than. So that one's going to be shaded below. So I need to come below this line. So for this line, we're talking all underneath here. And for the other line, it was all the above. So I guess it kind of looks like if I'm going to meet my goal, this is kind of the region where I need to be. That's kind of my adult and student. I got to be somewhere within there. And it looks like I'll make the 3,000, but I'll keep it under 250. So any ordered pair in there should definitely do the trick for me. All right, moving on down. Graph a system, classify the figure created by the solution region. All right, let's see what we got going here. We have a system of 4. So y is less than or equal to 5. So less than or equal to 5, y. So now we're coming down this way. Y is greater than or equal to 2. So greater than or equal to 2. So that traps us, I don't know why I did that. That traps us up this way. Then we got a couple slanted line, oblique lines in here. We have less than or equal to 3x plus 1. So 3x plus 1 goes up 3 over 1, 3 over 1, 3 over 1. Solid. And then 3x minus 4 crosses down, way down at -4, which is kind of off my screen a little bit, way down here. And going up 3 over 1, up 3 over 1, up 3 over 1. Oh, it looks like, since these two lines have the same slope, they are parallel to each other. So these lines are parallel. If I go less than the plus 1 line, that's shading this way. If I go greater than the 3x minus 4 line, that's going this way. And then you got the blue coming down, and then you got the red going up. So this will be the solution region. What shape is that? I believe that would be a parallelogram because all sides are parallel. All right, let's wrap up this last problem. We got to graph a system of 3 equations and then determine what type of shape it is. So the first one I'll do in blue. Y is less than or equal to 7. So that's a horizontal line. Crosses the y-axis at 7. It's solid because it has this bar right here. And if we're going to shade, it's less than. So we would be shading below that line. So I'm not going to scribble all over it, but that's where the shade would go. We do this red one. I'm going to solve this one. So I'm going to have negative y less than or equal to negative 2x plus 3. Multiply everybody by a negative 1. It's going to flip the sign around. So we end up with that. So my y-intercept is at 3. Be very careful. Here's where I screwed up earlier making the video. Is the scale goes by 2s. 2, 4. So you got to be kind of careful here. So if I'm going to go up 2 over 1, so I'm going to go up 2 over 1. It's really right here. Up 2 over 1. Might be easier just to go 4, 2.
And that equals 8. And then you just solve it like normal. So I combine
It's kind of goofy. What am I doing? Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. So it's really up 4, 1. Connect it.
So there's the x part.
Solid.
Of the answer. So
and then we'll do the last one in black. Right here.
I know it's going to intersect. Those 2 lines are going to cross it.
Oh, I got to do the shade for that one. So the shade was y greater than for the red. So greater than is going to be this way, this way, this way, this way.
So y equals 3.
Let's do the last one.
Or y equals 5. And that's how you can kind of complete.
2y greater than or equal to negative x minus 6. Divide everybody by 2, which means don't flip the sign. That's a negative 1x over 2. Divide by 2, divide by 2. That's negative 3. So we started a minus 3.
So if you look here,
and we're going down 1 over 2. So down 1 over 2. Down 1 over 2. Feels weird because it's really over 1, but scale's goofy.
They don't have a coefficient in front of it, so it's just 1.
And there we go. Solid line. No.
I'm going to move that.
And we are shading above that line. So it looks like my solution region, they got triple shaded by everybody.
For y. So I eliminate the y. So I'll have negative 2x
area
plus
right here.
equals 1.
All right. Hopefully this helps you out. See you.